Nice, thanks. Good to Omaha.
Wow, we have to consent to recording now. That's probably a good thing.
Oh yeah, it's weird for Columbia. Every time I go in, they're like, this meeting is being recorded. I'm like, you're creeping me out, dude.
Okay, what do you think
what
that
is that?
What the heck?
Oh, do you have any idea? I actually don't know what that is.
I've never seen that before.
Maybe I'm trying to think. I have the radar for meteorologist book behind me. I can go grab it if we need it ourselves.
Of course, you have. I wouldn't know where to find it though.
I feel like that isn't hail spikes. So I guess it could be, but my guess is there's some sort of. I mean, where's the radar? Is the radar like being dumped into the cold pool or something? So like it's being ducted aggressively or something?
Oh,
like in a really short like distance or something like that.
It's only at long ranges that this is showing up. Like really long range. How far does this get? It goes like
the edge of the. Could it be false? Could it be side lobe contamination?
I forgot what that is, but it could be. Yep.
Insightful.
Wow. 60,000 foot echo tops on these storms.
Wow.
This is going to be a big MCS heading into northern Missouri.
Ouch.
Finally, we have one initiating cell, but it's not tornadic. The only tornado so far was in southern Iowa, and that cell just completely evaporated. So.
Did southern Kansas actually get to over 100 today?
Southern Kansas?
Yeah, because the HER was basically right under the low. It was taking it to like 103 or just some absolutely brutal temperature.
Oh, yeah. Oh, yeah, it is 103. Medicine Lodge, west of Wichita, 103. 105 Salina. There you go. Salina, 105.
Ow.
2.65.
Yeah.
Feels like 110.
That's an ouch.
Yeah.
This is just a mess. It's not great for chasing. I know a lot of people. That's what all those little green car symbols are. Those are the chasers where they are.
Oh my gosh.
It looks like a lot of them started to ditch this and go south to this now. They're heading towards this one now.
Well, they do also look at the radar return where they were was probably not a fantastic place to be.
No. No. It's just a giant mess. Flash flooding. It's just like training over the same spot.
Well, yeah. I mean, did you see what the PWatt values were?
I didn't look at that, but I'm sure it was like over
like
2 inches.
2.3 or something ridiculous.
Yeah.
It's too early for the Zerzy sounding, but
you got some thunder nearby you, huh?
A little bit.
South of you, right?
Question.
Funnel cloud in Fort Pierce.
Sure, why not?
I saw a report of 4 inches of sleet in Ocala earlier, or Gainesville. So that was obviously a mistake. It was supposed to be rain. So do your thing, Colin.
Are we still waiting for people?
Fabian might be stuck in traffic, but otherwise it was only Fabian.
Okay.
Yeah, it was otherwise only Fabian, but something maybe came out of his control, which we had a bet that might happen. Sadly. He might join later, but otherwise, yeah, I think this is everyone.
All right. I mean, Jason and I are really good at stalling if you need us to.
Oh, we know.
We're very good at that.
I missed that though. I missed that.
So we ran all of our meetings. All of our AMS meetings were just one big stalling tactic.
Yeah.
Am I wrong?
No. Not really.
This looks pretty cool. This set. It's probably really laggy on your end, but
It's not too bad. A little laggy.
That is, you would think.
Is the mesosector visible? So yeah, I would expect this area to go up.
Does all of this data come with GR Earth when you get it, or do you have to get like extra things?
You can get the software and it comes with no data unless you subscribe to the data from Alliston House. And I just have an account. I think you could just sign in on Google, on GR Earth now. But new tornado watch now. Northern Missouri, Southern Iowa. There was supposed to be a lot of convection out here, but I don't think it's coming till later. I don't think it's going to be that as intense as they were expecting.
And this is the area that I was calling out.
Are you all right?
Is Sherry okay?
Her cat got a little excitable. I think she'll survive.
Okay. I couldn't tell if it was the cat or Sherry. I just assumed Sherry because why not?
It happens. Her cat's crazy.
Does anyone know how I can get back to Zoom?
No, you're stuck there.
I also could just stop you. There you go.
There you go. Yep,
I just
thanks.
stopped you instead.
That works. I never know how I can like switch back to Zoom settings when I'm, because if I close everyone's picture out, it's just gone for good. I can't like open it back up because the picture's always in the way. I just have to keep dragging it around.
Well, you are a man with many talents.
Okay, yeah, Fabian's not going to be able to make it, so we can just go. He said he's stuck in traffic jam for at least another 30 minutes, so we're just going to go on with life.
All right. So what do we got?
Colin's Steer show and Jason's show.
Well, that was your first mistake.
I'm concerned, but I'll take the chance. Take the chance.
And now this is when we learn if y'all did your homework. Which med-eds have you all done?
Oh, I can track them. Let's
Oh,
go.
we can verify.
In all honesty, not many. But in my defense, I have been waiting until after this Galapagos Physics 2 chaos because I'll have 3 full weeks to kind of just like focus solely on this.
She's done the meteorological chart one, Karsh, and yeah, just that one.
Yeah.
What? Cheryl's done everything basically. God.
I'm not even surprised. Cheryl's like always on top of
meteorological chart, basic satellite imagery, community preparedness, remote sensing, principles, convection, weather radar from fundamentals.
Yeah, but it was like over a long period of time, so.
That's true.
Yeah, I just recently.
On them.
Yeah, I started getting into them recently. I'm starting to crank them out this week.
Yeah, so he's done the meteorological chart and mesoscale.
Yeah, my goal is to do at least 1 or 2 before I leave for the trip so that I'm not too backed up by the time I get back. But
Janelle's also twinning with Cheryl.
On my planner, I have everything.
Janelle does many as Cheryl's done. They're twinning.
I was very thrown off by the drills for the chart one. because I thought that was getting me ready for the quiz, and it was almost completely unrelated. It was like an hour and a half of drills. Like, oh my God, I'm never gonna remember all these symbols just off my head without, using them in something.
Yeah, I don't actually remember exactly how that one went since I did that freshman year.
Same.
What's
But
which one is that?
The meteorological chart method.
one of the ones that Split had you do, like one of the first ones Split assigns.
Oh, like the symbols on
Yeah.
the
What the
Yeah.
thing that got me was just like this specific symbol stands for fog that's only on the ground, not blocking the sky, but is bringing visibility below 600
those are
meters. I'm like,
ridiculous.
oh my God.
Yeah.
Nobody
That was even on the
knows
quiz
those.
for it.
Oh,
You need
gosh.
to have the chart if you want to know what those mean.
Yeah, I was
You only
like,
need to know
oh,
like the
okay.
basics, like the comma symbol and the dot.
Am I
the
the only
two
Yeah,
dots,
like this
three
one's,
dots,
yeah, that I can do. Like, this is rain, this is snow,
the fog.
this is drizzle, this is fog.
Yeah,
what
that's
it
good
sounds
enough.
like is we're definitely showing METAR plots tonight.
Oh no.
That I could look at. I'd have to go back and if it's like the strings of each line in the description of it stands for certain things. I'm hoping I can jog my memory looking at it because I'm not sure if I remember the particular order. And they do a lot of, it kind of annoys me coming from a physics background where normally if you got numbers, you put your numbers out. They've got really wonky representations as far as I've seen about when they decide to cut numbers off of a distance and just assume that you know what goes in front of it, which once you know the format, I assume it's pretty easy, but offhand, it's a little irritating.
Luckily, you don't have to memorize much with professors at Florida Tech. Like, at
I
least the
figure
ones I've
I'll
had.
get used to it just by looking at it more. I just need it to pop up more in my everyday.
Mm-hmm.
You've gone through Ray. If you can get through Ray, you can get through anything.
We'll see.
Yeah. So, all right, there's that. Has anyone actually done any of this? You don't have to complete it. Has anyone at least looked at the one on SQTs?
On SQTs, I do not think that I have.
Yeah, I've looked at it. I definitely have not completed it. It's very large.
I haven't, like, I don't know, because all I know is I've taken AV Met 1 and a lot of that stuff has been sort of kind of covered. So I have that little bit of idea of what's going on.
Okay, then you guys did principles of convection.
Mm-hmm.
Yeah.
Wait, oh wait, no.
No, Joe, you haven't done that. Joe, you haven't done that yet.
I got thrown off because the check mark is right next to it. I'm trying to keep track on the education channel here.
I also showed you the Google sheet. You can check at any time. I update it as soon as you send them.
I need to look at that again.
I have it like little
find it.
highlighted boxes.
I'm sorry, I get buried in emails from like Dr. L and 3 other people.
Shoots, I feel that.
Do you want us to send a messenger pigeon?
That's an idea, but
it's more memorable than an email.
That's true. I'm wondering if Cassie, is the Google Docs linked somewhere in the Discord?
I should link that. No.
Because I could pull that up. If you have like a channel for important links of like documents that just get updated.
I like that. I can do that right now.
Can you guys work on that while we get started? I was just trying to get an idea of where everyone was.
Sorry to hold you up.
You're fine. I just want to multitask. That's all.
Okay.
Let's see. So, I don't know if you can hear the thunder in off my mic or not, but there's stuff all around.
Not
me.
yet.
All right. So, what do we need for convection, and what type of information would you look for to forecast it?
Sorry, could you say that again?
What are the ingredients needed for convection, and what information would you want to forecast convection?
To forecast convection specifically, I can't really put my finger on
Well,
that.
you need lift.
Okay.
There's 3 main ingredients I know.
Okay, yeah.
Oh, okay. I thought you meant lift by convection. That's my bad.
Well, I mean, if you want to really
blending
get into that,
terms.
there is such thing as dry and moist convection.
Yeah, you're right.
But I don't think Jason really wants to go into boundary layer meteorology at the moment.
Right.
Well, maybe he does. I don't know. Look at that face.
I wouldn't want to go into that.
So are you talking like lift and instability and moisture?
And then moisture.
Yep, that's them. Those are the 3. You get those a lot in Florida.
That's true.
I'm getting really confused by the wind here. I swear the wind goes in circles anywhere I stand.
Depends on where you are.
So
are
what,
you normally along the coast?
Yeah, I'm in Melbourne. So you're just going around campus, and just looking up at the cloud formations, I'll see, the upper layers going like out to sea, and then the lower layers coming inland and north. There's like, there's a lot going on. And then even walking around campus, I feel like I'll be getting hit from wind from off the coast for walking past the cafeteria, and by the time I get over to Link, it's coming from the northeast.
Yeah, it has a lot to do with the buildings too. Like where you are relative to the buildings, the winds shift around. They're like funneled around the buildings and stuff. Especially Crawford, I remember.
Well, Crawford's just a wind tunnel.
Yeah.
Is it?
It just funnels and like, oh my god.
Like on the north side of Crawford, it's like.
It's horrible. Like I'm walking in and I'm like, oh my god, I feel like I'm going like a hurricane force wind trying to get to the door. Oh.
Bad time for big umbrellas.
There's a reason why I had a raincoat, not an umbrella at all. But okay, so what type of information what kind of information would you want to forecast convection? What are we looking for?
I'm assuming we want temperature and probably rainfall would help, or just the humidity in general.
Yeah, dew point.
And then wind direction.
Okay. Anything else?
He's like
I guess if you're looking for like fronts or stuff. Because then you could see if you got warm air or cold air coming in.
Boundaries are important, like surface bound. So a front is definitely important to look for.
Areas of convergence.
That would be a source of lift. Whether there's a front or surface boundary, like a sea breeze is also an example of that. Sea breeze boundary.
What was the one of the charts that shows the flow of air currents? It keeps them generally parallel to the wind barbs, because those show convergence and divergence, right? So if you have, is it the streamline chart is what it's called? Okay, that one would be handy, because then you can see convergence, if you have, I've lost my train of thought, but I think you already said it.
Yeah, you could infer convergence too from like METAR, like enough wind barbs. You're looking for lower level convergence.
You do have to be careful if you're going to do that, though.
Is that because streamlines show higher in the atmosphere generally, or unrelated?
It depends on what chart you're looking at.
Yeah, I mean, you could put a streamline wherever you want.
Okay.
It's just streamlines aren't really even a meteorology thing. They're a fluid mechanics thing.
Yeah, but you could apply it to.
Yeah, I mean, air is,
because air is a fluid. Yeah.
Yeah.
So it's actually more basic of a principle than you might think. So yeah, that's definitely something you can use. What else do we got?
Wind direction, wind speed at different levels of the atmosphere.
Okay.
What are we looking for? Like terrain? Are we looking at sources of lift?
Terrain's a good one. I might generalize it more to geography, if that's all right.
Okay.
Because geography determines where you would have like pockets of warm air and pockets of cold air and like the thermals that rise up.
And yeah,
It can. Um,
depends on like
thinking a
the,
little bit on a bigger scale.
So are you asking more of like, I need to watch out for if we're close to the coast or if it's near a lake? I mean, how
That's a
specific do
good
you mean?
one. That's a good thing to consider. That's good. How about vegetation?
That makes sense.
Depending on what's there, vegetation can actually release moisture. I mean, I'm sure we can have Jason talk all about the corn. And
That's something I really hadn't considered, honestly.
I promise you, Jason will confirm. I'm not making this up.
yeah, it's true. I don't often look at that or think about it as like a way to forecast.
You need to read some more
direction,
Iowa
but
forecast discussions.
Iowa forecast discussion.
Yeah,
Oh, I haven't read those.
I
That's
remember I've seen it come up operationally.
It's like soil moisture and stuff, right?
Yeah.
And I guess lack of vegetation too, like city areas,
yeah,
would be a lot hotter.
Those
Good.
can have like heat island effect and could also enhance instability.
Yeah, the urban plume could be a whole multi-day discussion.
On whether that's going to be dry or humid.
I mean,
Urban plume or just
Yeah.
you know.
I'm at the urban plume. I mean, because depending on your like influence, if it's been raining a lot, it could cause more evaporation because it evaporates quickly. But if it has been dry, then it stays that way, and it could have a drier influence on what's next to it. I'm just kind of reaching for what you're getting at. I'm not sure.
Oh, so cities generally won't absorb water. It'll stay in general. I mean, yes, there is obviously still some penetration, but let's not get too micro scale here.
So you mean like, so the evaporation from water that's there is too short term to really consider?
Well, it'd be like it pools, right? The ground, cities don't absorb into the ground as much
Right.
as so your incoming solar radiation is being used to evaporate water, surface water, basically within cities.
Okay.
Whether that's important enough on operational forecasting or not, I'm sure the answer is maybe.
Well then.
yeah, it's not something I really look at. It's like to find scale.
Yeah, I mean there might be. I know there's definitely research on that. I'm sure if you want to go out and find it. It's very hard to know everything in this field.
So when you said one of the things you look for is vegetation, are you considering the specific type of vegetation that's there, or just that there's vegetation there at all?
Well, I mean, I guess you could if you happen to know, but I mean, I'm not looking at this like on the daily. I mean, I know, like, I have a general understanding of the area of the geography of where I'm forecasting. Like, I know the area between Melbourne and St. Cloud is mostly commercial farms, and there's nothing down there. I know the rough boundaries of the Orlando Metro. You know, in other areas, you could have fairly dense forests. I mean, you don't need to know every tree, but you need to understand how this could affect like differential heating boundaries and whatnot. But this is sort of like you spend 2 seconds on this. This isn't like let's spend an hour trying to figure out how the trees are doing this week. So I wouldn't.
So it's what you're. I mean, I'm just guessing here. What you're getting at is just kind of a quick assessment of your general area, like, okay, you know, we have a lake here, yes, no, we got trees in the surrounding area, this isn't necessarily like really urban, just like quick things you're looking at.
Yeah, I wouldn't even say I'm just even looking at it. It's just things that I kind of passively know.
You keep in mind, yeah.
Yeah. Like if you see something that looks weird on the analysis and you're trying to figure out, all right, is this real? Is there a problem with the data? And you remember, well, there is a lake there. So maybe there's cooler temperatures being blown off the water or something like that. Because even like a decently sized lake can inhibit the formation of clouds. And downwind of that lake, you'll see an absence of clouds for maybe a few miles or more, depending on how big the lake is and whatnot. And then all of a sudden there's clouds again. So you might think, well, that's weird. Why aren't there any clouds? Well, it's because there's a lake there. There's a local influence. So that's
it's because the water temperature is cooler and it's not heating up during the day. Like this happens. This is a diurnal thing. So you see it from Lake Okeechobee all the time. Like if you've taken weather briefing with Dr. L, he often like shows, wow, look at the cloud. There's no clouds coming off the lake.
Is it? Yeah.
If you take it in the fall, I'm sure he'll.
He's not teaching it though.
Like 5 p.m.
He's not teaching that anymore.
Viola's been teaching it.
Oh, why?
There you go.
So you guys have said all those things, but have you considered the temperature at 500 millibars? What about 700?
Don't forget 850.
Yeah, we can go through all the mandatory levels if you want, but there's reasons why I bring those up. More so because of tradition.
Do you want to explain why those are important or what you're looking for?
In a minute. I'm gonna get through the whole list. Okay, so you guys talk about this moisture, but how deep is it? Because right now, you guys said moisture, instability, and lift, but we haven't even established if this lift is going to be enough to do anything for us. We don't even know if we're going to be able to tap into that instability yet. And one of those ways you can have a better chance of doing that is be able to take a lot of surface moisture and moving it upwards. That's a method. There's a few different ways to do it, and I am not getting into an in-depth discussion on parcel theory. But one of the things you can do is, and this generally isn't a problem for Florida, is if you have a way of lifting a good pool of low-level moisture throughout the day, you can basically get a deeper layer of moisture, and that can lower how much you have to lift your parcel in order to get convection. It's not a guarantee.
Yeah, mixing.
But yeah, remember, not everyone here has even FMET1, so I'm trying not to get too crazy with terminology. But yes, is correct.
Would one of the things you would look for then be if you have colder air that's dry at a higher altitude? Because that would promote, if you have warm, moist air moving up, then that air would be more likely to drop and cause the whole thing to be mixing, like you said before.
So drier air could cause bigger downbursts if you have a layered dry air, but you can't have too much dry air like throughout the column, like throughout the atmosphere, or else like your moist air will mix out.
Right. I was asking, so would you look for it like in a layer? Like if you said to check, it's 700 millibars, what about 500? So if you're looking at layers, if your topmost one is a lot drier and your lower one is a lot more moist, then that would be a good sign for cloud development?
I don't know about
potentially?
drier, but definitely colder
Right.
would lead to instability, the lapse rates. If you're familiar with lapse rates?
Yes, I'm from a physics background.
Oh yeah. Yep. So you get steep lapse rates, and that's basically instability. And I don't know, Colin, do you know if you have dry air aloft?
I meant, dry, because the stuff I was looking at what Noah was saying that, you want drier, colder air. I guess it being dry in general isn't really for so much as you're saying you want it to be colder. That's what we care about more.
Yeah.
Okay.
Yeah, I
If
mean,
it's
dry air can certainly help. Of course, too dry and you're
Right.
too dry, yeah.
right. You're not going to have a chance to saturate the air. I mean, it's
So a temperature difference is more important than the difference in moisture.
yeah,
Yeah,
and
like you don't want it to be dry, too dry above it.
Well, right. And I mean,
If you
what's
have a
going to
dry
form?
layer, that can help actually enhance downbursts, which can cause severe weather. But you don't want it to be too dry, like aloft, or else
Right.
you're not going to get condensation.
yeah, so I mean, and also consider how the effect of moisture on that lapse rate as well. Right? If we got, if we're taking water vapor and condensing it, right? It's a phase change.
Mhm.
So
So if there's more moisture in it, wouldn't it cool more slowly?
yes.
Okay.
But so that's I mean that's what I was really getting at. Dry air also is often accompanied with adiabatic warming. So oftentimes you'll see that that dry air coming in is because of subsidence, which is going to create a cap, and that's going to basically create an inversion aloft, and that will make it more difficult, if not straight out stop you from having convection. Depending, again, it depends on the strength of it and whatnot, and if you can heat the surface to get over it, or it kind of depends on the situation.
Yeah.
So
It's not common that you get like a subsidence inversion, and then like that creates a cap that convection can break through. It's usually too strong of an inversion, and when there's a subsidence inversion, you don't have the dynamics for like convection in place normally. Like you're behind a front, and you're getting cold air advection underneath, so that's not favorable for convection.
although, like today, we did have the inversion form last night.
That is a different type of inversion.
It's true. That's not a subsidence, but it was the advection of warmer air. Did you get a chance to look at 700 and that thermal?
Me?
Yeah.
No,
It was coming off the Rockies.
Oh wait, are you talking about Florida or?
No.
I thought you said Florida.
That would be
in the
impressive.
I was like, what?
So yeah, so last night there was a pretty good thermal ridge. I don't know if I can really call it a ridge if it was technically closed isotherms. But a weak shortwave kicked off a whole bunch of warm air aloft over Kansas.
You're talking about what they call an elevated mix layer, right?
Yeah.
Is that what you're talking about?
It would be, yes. I'm trying not to get too crazy, but yes, it would have been.
I know that's just the term they call it, but it's basically, you could explain what that is. Like,
okay.
I could explain if you want.
You started the conversation, so I thought you were going to finish it, but
yeah, no. So it's basically very warm, dry air from the Rockies, like desert Southwest, that is advected. It's blown eastward over the plains, which is lower elevation. So it ends up being like an elevated layer of warm and dry air, which creates an inversion. And if you have it also enhances instability above it, because if it warms that layer, the air above it does not warm, so you get steeper lapse rates right above that warm layer. So it's often a big ingredient for severe weather in the plains or in the Midwest, because when even though it creates a cap, which can prevent a parcel from rising above that warm layer, if you get enough, there's several mechanisms that can decrease the inhibition in that layer for a parcel to rise above. But if you do get convection to break the cap, you have explosive thunderstorms. I don't want to get too deep into like how you erode convective inhibition and stuff.
So let's kind of take some of these ideas and let's try to apply it here. All right, so actually, yeah, why not? Let's do it this way. Do I have screen sharing, Cassie?
I forgot I was on mute. Yes. Jason noises, my favorite.
What?
I said Jason noises, my favorite.
When did I make a noise?
You just made one. You just made a weird one.
I don't think I
legitimately don't know what's going on.
Oh, I thought he made a weird noise. Okay.
I don't have a response.
I don't respond for me either. It's fine.
300 millibars, everyone. As Jason and I die of confusion.
Jason noises.
Okay, Jason noises are the best, though.
This is not a level I look at very often because I don't understand it.
All right. So anyone want to take a guess? So what we got here? Ignore the pink stuff for now.
Oh, really?
Yeah, the pinks get in the way. Pink like there.
I'm also not convinced that the pink also isn't being influenced by the convection, even though this isn't a cam. I'm pretty sure.
This is the wrap analysis, right?
Yeah.
Pretty sure. I don't really know how that analysis works, so I don't know if it's influenced by convection or not. I assume it might be.
Well, I'm a little skeptical that this is a synoptic feature right here. How about that?
Oh, yeah.
Which is why, and that is exactly where the.
I was like, why was that a different color? I thought like it was part of the map.
Yes, I have the ability to change the SPC maps now.
Whoa.
All right, so what do we got here? Let me kind of.
Can you like point where you're going?
No, because now it's wants to erase. It's being difficult.
Are the black lines here lines of equal height or?
Yes.
Okay.
That's impossible to see. That's horribly drawn, but what's going on there?
Isn't that where that decaying front was?
I can
Probably
see that
not at 9 kilometers up.
I can see that the wind barbs
you can
totally
have
changed direction right there.
Sorry, I cut you off. What did you say?
I said I can see that the wind barbs totally changed direction right there. The ones to the left are coming from the north, and the ones to the right are coming from the south.
Sure. We want to use some. If you want, you can use some math to describe that. Yeah, I'd run away too, Jason.
Wait, which feature are we looking at? Oh, wait, I see you drew it now. Okay.
Are we clear on what I'm pointing at? Is that clear?
Is that the yellow stuff you just drew?
Yes.
Yeah.
Okay.
Okay.
Okay, I'm on the same page
Make
now.
sure that's understood.
And we're looking at the direction of the wind barbs. Is that what you're trying to focus on?
Well,
Well,
that's
what
what I
is it?
brought up. I don't know if that's what he means.
I mean, I wanted more of a. I wanted the.
Is it a trough?
Eight lines.
Yeah, I'm looking for like the second grade answer here, not the PhD answer.
It's
So, yeah.
dotted lines.
Thank you, Jack.
You
So,
said the
yes,
second
this is a
answer.
trough.
Okay.
That's a trough.
Was that a second grade answer?
Yeah, that's not
So-
really a second grade answer. The dotted lines is.
So I went over the charts before. What makes that area identifiable as a trough without that dotted line there? That's sometimes included on these.
Well, you'll
I guess it's something I'll just get used to identifying by looking at it.
especially since hand analysis is sort of not as common to be seen, at least on the internet. It is still done by lots of offices, and just most notably SBC still does a lot of hand analyses. But probably out in the wild, you probably won't see anyone marking up charts, even though they should.
Are you asking how you would identify that, or?
Yeah, his question is, how would you know it's a trough opposed to anything else? So,
Is it the dip in the height pressure? So are you just looking between those two? The one that's pretty much at Virginia and then the one that dips down to Florida? Or is that unrelated, really?
well, they might be two separate troughs, but
Okay.
just kind of, yeah, I would say they're two separate ones personally, because I don't really see it dipping.
Well, the larger scale
Yeah.
trough, he's definitely the one you outlined. That's a larger scale trough.
It is. I also outlined it because it's over Florida.
Ah,
Mhm.
so it's the dip in
Yeah.
the 9660 that shows there's a trough, you're saying?
And you see the one above it too also has the dip.
Right,
in
as that little
New
one
Jersey.
there.
Yeah, today's not the best example. This is a pretty decent example.
Yeah, that's the one that's leading to the severe weather in the Midwest. It's like they've been calling it a positively tilted trough because it's tilting southwestward as opposed to like southward. A negatively tilted trough would be it tilting to the southeast. But this is clearly, it's almost like east to west. Like,
oh, sorry. Yeah, I was talking about the Florida.
oh
ones.
no, that one is slightly positively tilted, but not nearly the one in the west.
Right. I get that. So, yeah. So a reminder is that this is a constant pressure surface.
Right.
So these are height lines.
Right.
So, I mean, we really don't. You go ahead, Jason.
I almost think of it like, if I don't want to think of it as constant pressure, I almost think of the lower heights as lower pressures. But I mean, that's not what it is, but you could think of it as that. It's almost the same thing. But it has to do with, hydrostatic balance and stuff like that. What do you call
Okay.
it?
I think I get what you mean by that, because like the height, the pressure dropping in height is the same as like the pressure dropping at a certain location.
Right.
Okay.
All right. All right. So the only thing I'm really wanted to note is, although this is a pretty weak trough, a troughs in general, there's a whole. Basically, all of Dynamics 2 is basically all of Dynamics 2 is why what I'm about to tell you happens.
No. Oh, sorry.
You're right.
Hold your streams to the end of the lecture. Thank you.
I'm not okay.
No. In general, a trough, or in the eastern part of the trough, will have some amount of vertical motion. Like I said, I am not going over the details of why that is.
Why that is. Yep.
Um,
That's just where you're looking for a
Joseph,
larger
have you
scale.
taken dynamics yet? Or no?
Joseph.
I'm sorry, I didn't hear what you said. Could you repeat that?
Have you taken dynamics yet?
No, I have not. The only thing I have taken, just kind of a rocky start because of when I joined, but what was being taught when I got here was climatology. So the only thing I have taken is climatology. The rest I'm basically picking up freehand.
Yeah, no worries.
Until I take it.
I wasn't sure how, because you're a grad student, right?
Right.
Yeah, I just didn't know how they handled you guys exactly.
It's a little all over the place.
Understandable. But I think you would really appreciate, I mean, if you want to talk later, we can go a bit more over why. But you'll probably appreciate the math on it a lot more than the others would.
What about
Math
me?
doesn't scare me, but I will say that my memory's not the best. If you want me to solve a differential equation, we're gonna be here a while.
I don't think Colin's gonna make you do that.
That's a fat move.
Nah.
I don't think Colin even wants to solve a differential equation.
I didn't say we were gonna solve the equation. I just said we would show it.
You should scar everyone. It'll be fun.
No, it's honestly more calculus 3 than anything else.
Oh, that's not so bad.
Oh, I'm taking that in the fall.
And
It's the same as calculus 2. It's just with an extra dimension tacked on.
That's
I haven't
fine.
done much,
that's
even in grad school. I haven't done much of any solving differential equations, only like looking at them and knowing what they mean.
Well,
like
I hope it stays that way for you.
Yeah, I'm going into advanced dynamics next semester, so I might change. The prerequisite is partial differential equations,
Oh,
which
God.
Oh
Oh
no.
no.
which I have not taken, but they
Uh,
just dropped the requirement, so that's lucky for me.
good luck.
Oh.
good. PDE was a nightmare for me.
Yeah, I hear everyone fails it, which is why they dropped it from
It's
the
really
program
hard.
at Florida
I think
Tech.
the trouble is just a lot of people are really bad at explaining PDE.
I'm
Anyway,
so glad
I
I'm
don't
not
mean
taking
to.
that now.
I don't mean to drag us too far off topic. What were you saying, Colin?
So my main point is, although this trough is pretty weak, so we're not getting a whole lot of help from it. But in general, troughs are a source of vertical motion.
It's important to distinguish when we're looking at upper level charts. This is called like synoptic scale meteorology, so it's larger scale. Right. When we're talking about vertical motion with these, it doesn't necessarily cause convection or trigger it. It just preconditions the environment and helps convection like maintain itself and grow upscale. There's just a lot more energy like available when you have that kind of synoptic scale lift.
I would imagine one of the bigger things you'd be looking at if you're looking at this scale is whether you have a jet stream coming through or not.
Yeah, in Florida, you're probably not.
Yeah. It's a little
maybe
too
in the
low.
winter.
Yeah, maybe the winter. Maybe though. But this
and even this time of year, you don't get much, even in the whole CONUS. It's like in Canada right now, the jet stream is pushed so far north.
It's right there. It's off the map.
There's a subtropical jet coming in a little bit.
That is true.
Ooh.
It's also going right through So I'll go down to 500. So we got another little trough here over dipping down. This is probably some amount of Appalachian influence right there. Not that I want to get into how that works.
Funny how our severe area today lines up exactly with that little, like you don't need that much flow. For severe weather, you look at this a lot. You need some enhanced flow because it creates shear, and shear is an ingredient for severe weather, essential. Not necessarily essential because you can get severe pulse thunderstorms in Florida and you don't have shear with that, which is why they're very brief. But that little area of 500 millibar 40 knot winds is where we're having severe weather today in Kansas, North Kansas, south,
and then
eastern Nebraska.
In contrast, Florida, there's almost completely light winds.
Yep.
But
and
one thing I like to eyeball is the temperature at this level. I think the Florida Tech rule of thumb, anyways, is about -7, -8 for some good stuff.
Yeah, it's a good indicator of lightning too in Florida, I've noticed. If you have warm, if it gets like greater than -6 or 5, your lightning activity tends to be a little less intense, unless you can get a really intense updraft, like up to 60,000 feet. But the colder it is at 500, the more lightning and the more intense your updrafts can be. They don't even have to go as high to produce lightning.
And then we can go to 700. So again, we get temperature information. Although you generally don't get, at least in the summer, you don't get a whole lot of temperature advection in Florida. Though you can get with the some slight variation, of course. But generally like 12 Celsius is kind of, it starts to get a little warm for convection at 700.
I can't even see what I see. 8.
Yeah,
offshore.
I don't know why it's not analyzed.
Where is like 10? Is that, I assume 10 is the one to the west?
Let me see if I can do any. Okay.
Oh, there it
no,
is.
10. I see 10
Louisiana.
now. So
Yeah.
you guys are like, I think you guys are like around 7.
Yeah,
that's what it looks like.
About right. So there's.
It's just hard to tell because there's so little.
Yeah, I don't know. It's kind of weird how they're. Anyways, so that's probably okay. So this is mid-level moisture here that they're plotted.
Relative humidity.
Yeah. So that's pretty good. Another thing that I like to use, so if you go ahead, and some point, I'm sure we'll talk about this to show you guys, is there's a climatology by the Tampa office that has, they took a mean wind vector from 1,000 to 700 millibars, and they did they looked at basically the ridge placement, axis placement over Florida, and timing and location of sea breeze events.
Yeah, I just looked at that the other day because you sent me that link last week, I think.
Yeah, so as long as the ridge is firmly in place, it's pretty good. And I'll generally spitball that average layer, and I'll just use 700. I'll look at the other layers just to spot check it, but generally I'll use 700 for that. With the ridges right on us, generally there really isn't that much variation, at least in the low levels anyway. So
can't really see it on this though.
Yeah, this is not a good example at all.
Yeah,
this is actually a terrible example.
If you go down more, you might be able to see where the ridge is.
There's 2 options. This is just the, yeah. So mid-level winds are pretty light today, and that's why we're getting these storms sitting on top of us.
At least in Orlando.
Yeah.
East Coast, you have onshore flow, so the sea breeze move too far inland and you have subsidence behind the sea breeze, so you don't get storms along the coast on days when you have an onshore flow like this.
Yep. And of course, you can go to 900, and you kind of have the same information. It's kind of the same info. Winds, temperature, moisture. It's all kind of the same info at different levels. That's not to say it isn't useful. But so, and we kind of just, so I'll spend a quick look at that. I won't spend too much time. Certainly not as much.
Sorry. Can you go to surface?
Yeah, I will. Let me go
MSLP. Yeah, there you go.
So
that's weird. The ridge axis is like almost an arc to your north.
Yeah.
It's also, like almost coming down out of the Carolinas, the ridge axis.
So this is quite moist. Personally, I don't like using dew point as much. I prefer to use mixing ratios myself. But that, however, I mean, dew point's definitely more common on most places in our surface charts. So I kind of get what I get. So I do want to make a point about that because we can do mixing ratios. Don't worry about theta for now.
I usually, they're interchangeable for me. Like I usually look at dew point, like they're pretty much the same. They're almost like proportional.
Yeah. Talk about that later. So, I mean, I kind of agree at the surface, but we start transporting things vertically, then not so much. So this is surface mixing ratio, which honestly, 18 to 20 is kind of a lot, even for Florida. I mean, that's pretty good. Well, I guess I said going to 20 would be a lot. This is pretty decent moisture there. But I prefer to look at the lowest 100 mixed layer, because you can get like a really shallow, especially in Florida, you can get a really shallow surface, high amount of surface moisture, but it'll be relatively dry above it. So this will account for the mixing process we were talking about earlier. This kind of stuff goes into like CAPE calculations and whatnot as well, or it can. That's one way of defining your parcel. Yeah, I personally prefer to use it. There's also good reasons to use it, not just my own personal feelings. One of the things I also like using the mixing ratios for, to this higher, is like wet microburst forecasting and whatnot as well, but we won't get into that today.
For that, I've never looked at this chart. Are you looking for like lower values for microbursts or higher mixing ratio?
Well, I'm looking more for, I think generally what I'm going for. I'm trying to remember the best way to describe it.
I never thought about using this chart for something like that.
Yeah, no, it's based off of some of the reading I did. I'm just trying to remember. I'm sure you've seen theta E used. I'm sure you've seen theta E used, but I've also used it for that. And then I kind of like it for just general moisture as well. So another thing is the precipitable water. My personal experience is that in Florida, it's really widespread if we're around 2 inches or more. It can happen at lower values, but my experience has been it's a lot more widespread if it's at 2 or more. Do you have any other comments on that, Jason?
No, I agree. Thunderstorms when you're about when you're just above 2 inches, they're pretty widespread. It's interesting to see. Did you like go back in time there or something? What happened? It changed. Go up to, you see where it says -0, -2?
Yeah.
Can you go back?
Well, that would be back.
So I see. Forward. I guess it just updated or something because it just changed. But it's interesting to see the West Coast has higher values right now.
Well, that's also where all the convection is. So
it is. I mean, so it's probably influenced by that.
Yeah.
How high can it get?
How high can it get?
Yeah.
You should look at it in a tropical cyclone, like in the core of a tropical cyclone. It's like, it could be like 4 inches or something like that.
Oh, wow.
Yeah. Yeah, I mean, this particular calculation is the lowest 400 millibars. So this is just like lower to mid-level moisture. Obviously a tropical storm is depositing moisture quite high.
Right.
So that's good. I think the weather radio is going off.
Nice.
It's not a test.
No, it's not. I guess it's flooding related.
Flash flood. There's no flash flood. So I don't know.
I guess it's flooding. Anyways, as the weather radio goes off, also, if you have high values like this, there's 2 or more in light winds, this is also a pretty good recipe for flooding. So that's something also to be mindful of. That's also one heck of a stratiform region right over Miami. Oh, it's gonna be raining for a while over there.
Over Miami?
Or not Miami, sorry, Tampa.
Oh, I was gonna say, I was like, Miami's got nothing. Like, wait a second, yeah, Tampa has a lot. That makes sense.
Yeah, I mean, if the Melbourne radar with the being is still extremely broad and still at 35 to 50 dBz, then yeah, it's gonna still be raining over there for a bit.
You can have some sprites over there.
Probably.
Those big positive CGs.
Except it's directly west, so ha.
Dang.
Yeah. A telescope.
All right, so let's introduce Cape, which is 9 o'clock at night. It's a terrible time to show Cape values. It's actually right now. So this is one measure of that instability we were talking about. My general experience is once the mixed layers around 1500s when we'll start getting cumulus fields developing here. And we'll probably get into 2 to 3,000. I mean, 3,000 is a little high for Florida, but within 2,000.
Sometimes you get like a big punch of dry air coming around the southern side of the ridge, and you can get like Cape to go down. It's not that common, but it can happen like in
mixed
the summer.
layer. You get mixed layer Cape.
Yeah.
Yeah, well, that makes sense because you're bringing in drier. You change the mix layer.
Right. I'm just saying, like,
yeah.
Sometimes you get like a weird pattern where a bunch of dry air comes in off the ocean, like in the mix layer, which is kind of funny to see in rainy season. I don't like when that happens. I like storms.
So low-level lab traits, generally, I don't really care too much in Florida in the summer because I know it's going to get there eventually. I do pay attention to mid-level though, because that will be a little more. Because I mean, have you seen us gotten to a lapse rate of 7 Celsius in the summer, Jason? I'm sure it's.
I have not seen that.
6.5. I feel like we're doing pretty good.
Yeah, normally I see it like less than 6, so it's pretty good that it's
Yeah.
that
So generally
area.
our mid-level options are a lot weaker. Anything? I mean, there's a few other things I think I'm gonna kind of hold it off there. There's a lot of other stuff you can go through. Some of it more useful than other for Florida. And the deep moist convergence is kind of fun. Maybe more in the morning. But as you can see, they're using that mean mixing ratio again. Is there any questions, anything you guys want us to go over? I mean, I feel like this is I kind of want to address everything that you guys might more be on. I'm kind of the goal today was just to kind of get you guys thinking about types of information, about what you need and the types of information you might want to obtain, and to kind of go over some charts on how to obtain said information. I didn't really plan on going super detailed into forecasting of the process or.
So is this a program or a web page?
This is a NOAA web page.
Could you link that? Because I'd love to save that. Just in chat real quick, if I can pull it.
These are the charts they show all the time. Being at
I'll stop here for a second.
University of Oklahoma, since the SPC is right here, that's like their site where they show their meso-analysis. So we always look at those charts.
There we go. Thank you. I've been slowly saving a lot of links and names of programs from all these lectures, so
Same here.
Stockpile.
So let's go into surface, because you can get a lot of information from the surface still. I think I'm gonna hold off on soundings tonight.
So yeah, let them do the med ed first, because once they do a couple more med eds, you can do another one and like go over stuff in the med ed. Because Janelle had that idea of doing the med eds and then like going over what's in the med ed, like a general, if anyone has questions, comments, concerns, or anything needs to be explained. I think that'd be best.
All right, so
come back and do you and Jason. Jason can come back. Jason's fun. You guys are fun when you guys are together. I like ship it.
I'm on vacation next 2 weeks. Or
you're on vacation? Where are you going?
I'm going to Connecticut to visit my family and friends. But
Dang
then
it. I was hoping he's coming to Sebastian so I can come and just hijack you.
Well, you might be able to, because right after that I'm going to Florida for 2 weeks, 2.5 maybe.
Dang, I don't know if I'll be there because I'm going to Sebastian next weekend for 4th of July. Nuts. Hopefully I'll tell my mom, I need to see Jason. We're going to Sebastian again.
I'm sorry to say, but I've actually got to go. I'll have to catch the rest of this on recording.
No problem.
Man.
Thank you, Colin. Thank you, Jason. Thank you, Cassie. Catch you guys later.
Have a good one.
See you, Joseph.
Yeah, next week really is. All right.
That's how I felt. I was like, wait, June's almost over.
Anyway, so we'll still carry on with our surface-based information. Yeah, so where do I want to start with this? All right, start calling things out, everyone.
Ooh, I like Orlando's.
Okay, the way you're teaching right now is exactly what they do in my class for the severe weather forecast, and they're just like, so what do you see here? Start calling things out.
I don't know if that's a good thing or a bad thing, but I'm just gonna roll.
I don't know, but like I know they didn't do that at Florida Tech. You just like know how they would do it here. Funny.
MCO. I just liked MCO. It looks well, something just updated.
All right, since you're insistent, tell us all about it.
Oh shit. Oh, I'm recording. Awkward. Well, you see, there's MCO. You know the wind. Okay, sorry. The wind bar is really hard to read, but I see. Is that 30? It's very hard to read the wind bar. I'm like,
it looks like 25, I think.
25, and then gust is
30 now.
Yeah, 30 gusts.
Those gusts are pretty high. And then you can see the symbol is talking about thunderstorms.
How
Got
can you
that.
see the gusts?
The red line by the wind bar.
Oh, I've never
That's
seen that
Not a
before.
standard, by the way. That's literally only this website. So I wouldn't.
Okay. I was gonna say I've never ever seen that.
That's why I picked that one. That and because of the IFR condition too. Because the red, which one's red? Is that MIFR or is that VIFR? No. I always mix up the colors.
IFR is not a thing.
Oh shoot. I mix up the different colors of which.
So keep in mind, it's literally below you on the screen.
Oh, IFR. I didn't see it.
The most important things for you guys to know is to work smarter, not harder.
Yeah, if you look below, you can see what everything means. I didn't see that. I'm thriving. It's fine.
Today on the awareness box.
So that symbol there is what? Thunderstorm, and what's the dot over it?
So, fun fact, you can technically report thunder without precipitation.
Oh,
So the dot's indicating precipitation.
okay.
I have the TMCO radar pulled up, and there is like a cell just to the north, and there's like it's getting outflow.
I'm
from
sure.
that. Is it out of the northwest? Is that out of the northwest? Because that's what I'm seeing.
Yes, that's the barb is showing up.
Yep, that's the outflow.
So
I haven't read these in like 3 years.
I've gone over these maybe twice or 3 times in lessons, and I still can't remember them.
You want to see me read it?
Oh, I have to read it too.
Yeah, show up.
Show up, Colin.
All right, Orlando International Observation. 2025. So is that right? Okay, really? It's 20. Yep, that's right.
No, but it's disease converted to 25th.
I know. I didn't know what today was local. It was converted because I have a UTC clock. I just don't know what today was.
Oh, that's fair.
So 25th, 0107 UTC, which was about 10 minutes ago. One's 310 at 23 knots, gusting 29 knots. Visibility 1 statute mile. The RVR for runway 35 left is greater than 6,000 feet. Heavy thunderstorms, rain, mist, broken 1,500, cumulonimbus, overcast 2,500. Temperature is 24 degrees Celsius, 2.24. Altimeter is 30.13. Remarks. AO2 is just an automated sensor. It tells you the type of sensor it is. Or what type of, well, it is automated, but this is not automated. It's actually a human report, but it gives you the sensor type. Peak wind was 320 at 29, and it happened at 0106. Lightning distant west and northwest. Rain began at 04 after the hour. Visibility southeast, so that's probably southeast is 3 miles, so that's probably a tower viz. So that was a human visibility report there. Frequent lightning, I think that's cloud to intercloud,
cloud to ground, yeah.
Overhead, west, southwest, north, northwest. Thunderstorm overhead, west, northwest, stationary. The P's are is not a precipitation. I forget if that's what the hourly. I forget what the duration is there. And then the last part is basically just the temperature and the dew point to 3 decimal places instead of just the 2 in the rest of the standard text.
Nice. Beautiful. Where's the reaction? Applaud. Wait, where'd it go? Oh, I got scared. I thought I exited Zoom. Okay, applaud. There you go.
Yep. So that was a mouthful to read.
You said pick one. That one was interesting.
Meanwhile, at the executive, like, what's up? What?
Yeah.
Like, what's the problem?
Melbourne's
yeah.
just chilling.
So this is. I mean, I feel like. I mean, is there anything you want me to go over here with this? I mean, I think the reason why we look at them is pretty obvious.
Mm-hmm.
not necessarily the best to find sea breeze. Because at least this website isn't. And as a west site, it's probably okay because that gets updated more frequently. That's like 5-minute meters, which is a little better for that. But and generally this is only updated every hour unless things drastically change. So that might not be so great for your sea breeze identification. So it could help.
For that, I don't look at this at all. I look at underground wind directions.
Yeah.
Because there's a lot of networks. And I mean, they're mostly on the coast though. But then I look at the radar to see where the sea breeze boundary is. Like a strip of low reflectivity is showing up.
I think I'm more partial to satellite, but at least
satellite for a sea breeze?
Yeah.
I mean, visible, yeah, you could see it, but
I do it all the time.
Radar is the best for a sea breeze. I mean, satellite, you can see it as long as you have enough moisture, because you have cumulus in front of it and then nothing behind it. You can see how it gets more puffy right along it. I love watching sea breezes.
All right.
I'm always hoping it won't blow west of me, because then I know I'm not going to get any good lightning storms.
He likes his lightning.
I don't like being behind a sea breeze.
I don't either.
Unless it's close by, because oftentimes you get a storm to blow up and then it'll just blow a little bit behind the sea breeze, and that's where you'll get the worst weather.
Yeah, can happen.
Most people do like being behind the sea breeze though, because it gets a little cooler and sunny and a nice breeze off the ocean.
The sea breeze blew past us today, and we didn't get any storms. Not a single one.
Mm-hmm.
Jason, that was very close and very high pitched.
What, the lightning?
The thunder.
Oh, thunder. Well, hey,
I can't even hear it.
Lightning was high.
That was
we can't hear anything in your background.
That's actually really impressive. And it looks like there might be some more stuff firing off just to the south of the airport. I'm seeing, let's take some sort of alpha boundary convergence.
Are you central?
I'm in the Orlando area.
Oh, okay.
Yeah, he's just west of Orlando.
Center, by the way.
What?
Said Orlando is not in the dead center of Central Florida.
No, I know. I meant more central than the coast.
I am about 80 to 90 miles away from Melbourne.
Yeah. My parents are down in Winter Haven, so to the southwest of Orlando.
He's Winter Garden. He's the other winter. There's too many winters in Florida. It bothers me.
There's actually more winters than that. But
Winter Garden, Winter Haven, Winter Park.
Yeah, they had some
frost-proof.
That went well for frost-proof, by the way. You should look up the 1980s freezes if you're interested in how everyone. Yeah. So I know people in Winter Haven.
They're getting a good storm right now, Winter Haven.
Yeah, not too far from where they are.
Is there any questions y'all have? Any pressing issues, things that don't make sense?
I don't know. I'm just trying to absorb most of it right now.
You know, if you say no, I'm just going to tell you to make a forecast, right? Like, I established this already.
That's terrifying.
The problem is I don't know what I don't know yet. That's what I'm trying to figure out. I did spend a long time on SKUTs today.
Oh, trust me, forecasting will teach you exactly what you don't know.
Which is pretty much everything right now.
Exactly.
You got to let the storms teach you things. You got to...
Which they don't do enough of at Florida Tech. They don't really do many, they don't do many real...
And do you want to go over models?
Sure. Do you want me to do it, or do you have something up?
So I can say that I'm personally, my favorite is Pivotal Weather.
Me too. I mean, it has become that. Just like the recent upgrades they've done and everything, it's great.
Oh yeah, I subscribe to the premium stuff because I think what they do is
same. You could look at soundings from the Euro with that, like.
Yeah, I know. I mean, I wish there was a broader coverage area, but I know they're getting there. They've done a lot of great work in the last few months. I mean,
yeah, I can't imagine the amount of people that have dropped like from chocolate tidbits because that used to be the thing, and now it's this.
Yeah, and chocolate tidbits still great, and really, and I'll still. I mean, I still do use it.
Same, like for a quick view of the GFS, I use it.
But I mean, this is arguably. I mean, this is. Even if you choose, you still get the Euro, even if you choose to not pay for it.
Right. You don't get that much more, but it's what is it, like $3 or something like that? What is it?
I think it's more than $3, but it's really cheap.
It's pretty cheap.
It's cheaper than all the competitors. How about that?
Yeah.
Like if you're not, I mean, quite frankly, if you don't want to spend a lot of money on things or you can't, Pivotal Weather is a good investment.
I mean, you could get most of what you need without it, though. Like,
yeah, well, if you want to.
There's very few things you're restricted from.
Well, there are some products you don't get, though, too.
Some what?
There's some products you don't get.
Yeah. I only come across, like, the Euro soundings you can't get, a couple of Euro things, and it used to be you couldn't get the FV3, but now FV3 is operational, so you get it anyways.
I don't think you get. Do you get blended models, the natural blended models, or no?
Oh yeah, that's another thing you don't get with the free version.
I find that blended models actually works quite well for Florida. For temperature.
For temperature, yeah.
That's y'all, cool. FYI, I'm gonna have to drop out in about 10 minutes or so.
That's fine.
Okay. So we'll be this quick, right?
Yeah. So this is actually a really decent. So this side of things is more very large picture. It's
the
fine.
Two go-tos is ECMWF high res and GFS are the two go-to models, really.
Yeah.
That one's the Canadian, the GDPS.
Yeah, this is probably. Well, I don't think. I guess it is global models. I guess they even have a domain down here. Although this could be useful if you find yourself forecasting for like extreme northern United States. So then we have the regional modeling. So this is roughly in different resolution. If you go into lower resolution, there's different things you have to do with the physics packages and the models. The difference between here and here is a little more of a gray area. And that's actually what they call it, is that's literally what it's called. But this is really, you would be looking on this side of things for only really big picture. To an extent, that as well. The meso analysis is based off of the RAP. I'll use NAM for that sort of for like a few more days out.
Yeah, like three days out usually, because you can't get that with the convection allowing. Those are the best for looking at convection, obviously.
So, and I use it more for basic patterns. Like I'm not
for patterns. Yeah, you're not looking at the rain QPF products very much.
So I'll like if I'm interested in by Wednesday, is the ridge going to shift on me? That's what I'd be on more this side of things.
Yeah, it's a little higher resolution picture than the GFS or European.
Yeah. It might even have different parameters. Actually, I'm sure it has a few different parameterizations, but the her or the HRRR, whatever you want to call this. This is generally what I'll do for short-term pattern and for assisting in storm mode.
Hourly update, rapid refresh.
So I don't really care about exactly where it's putting the storms or exactly how strong they are. I just care that it roughly has the right structure. And it can give you, and it can assist in diagnosing sort of that multicellular pulse idea that we were talking about.
I mean, if you just look at like, it's funny because we learn to use everything other than like just what the models show. Like we learn to look at the ingredients in the setup and everything. And then our professor, he goes and opens up the reflectivity product just to look at the model simulated radar. He's like, let's just look at this, see what the model shows.
It can be very, very wrong.
Oh yeah. I mean, I will look at that just to look at the general area where that it's actually initiating convection, but that can also be very wrong where exactly it initiates.
Yeah, it may or may not be helpful for timing.
Mm-hmm.
It more than often, it's somewhat helpful. I mean, if it's all you have to go off of, you know. Besides just taking a guess in your head, exactly.
Guess in your head, I get the whole climatology. I think there's been almost times where I would go for the climatology then.
No.
So I guess our point is be careful. They're a great tool.
Especially, you have to look at if you look at our meso-analysis or the radar or satellite, you have to make sure that the model is at least remotely resembling what is actually happening at the current time, because the model was initiated a few hours back normally, and it'll show what the current time should look like. You have to make sure that it's close or almost matches what's actually happening, because I notice a lot of times it does not match, and it does terribly with the forecast afterwards.
And
you can't trust it.
And you can actually have a situation that even though it's absorbing new information to its initialization of the storm go, it actually can get worse with time.
Okay, I had that experience recently. Because I'm a dumbass, so I'll chase a nocturnal storm.
Oh,
well, isn't that what you're researching anyways? So.
And it is what I'm researching, but
well, that makes sense then.
Yeah, I mean, it's not part of the research to like drive into it, but I just love doing it. I mean, I'm not chasing a tornado or anything. I just want to intercept a good storm, even if it's like in the middle of the night.
Not driving into hail cores.
Yeah, so I almost did that. I did do it once. I put myself right in front of it. It was like the historic hailstorm that hit Norman a few months back. I was right in it. I had to shelter under a tree. That was a lot of fun.
Oh, you picked a tree?
Because there was nothing. I was lost, dude. Like I was not near a gas station. If you look at my YouTube video, you see exactly what I did. It was terrifying. It was really, because the stones were baseballs. Like,
oh gosh.
Oh my.
I mean, maybe not exactly where I am. Like it was 2-inch diameter hail where I was. But then like a few miles away, moving into Norman, they had baseball sized hail, wind driven, like 70-mile-an-hour winds. I had 70-mile-an-hour winds and like 2-inch hail.
Oh my god.
So it was just sideways hail. It was like death if you were outside. And my car was completely spared.
Wow.
Because I was under that tree.
That tree saved you.
I had one thunk like on the roof. And that's when I was like, oh my God. So I booked it under the tree. And then I had nothing else. Because I have one little dent right on the roof. But luckily it didn't hit a window or anything.
That's crazy.
But anyways, I was gonna say, I was watching her all day that day. Not that day, but more recently when I went after another nocturnal system. The her was showing the right solution like all day up until like 18Z, and then it was just wrong. Every run after that, it wasn't showing the right solution. Like all the convection was in different places or wasn't showing up at all. So the her can like often do well at about 12 to 18 hours out, and then 6 to 0 to 8 hours out, it'll just fail, which makes no sense. But so you just have to be careful.
On that note, I gotta head out, guys.
All right, we just want to wrap it then, because otherwise we're gonna be stuck with just Karsh.
No,
Oh, poor Karsh.
That sounds so bad. I love you, Karsh.
And it's too bad because I was hoping on getting you guys the forecast. Notice have Karsh give us the forecast.
Karsh, like, I gotta
go really bad. I've had to pee for the past 30 minutes, and I'm just like, but I've been so interested, and I'm just like, okay, I'm gonna concentrate. Maybe I'll forget about the urge to pee.
Well, I've got really early wake time, so I'm out. See y'all later.
Bye.
See you, Cheryl.
Bye.
Karsh, do you have any more pressing questions?
Not really, but it's been really interesting. Like, as I said to you earlier today, like, I'm really new to the major, but it was cool that at least I knew like METARs and like, I had some basic knowledge so I could follow along, but it was thank you, Colin. Like, you did a really good job of like, just like, your stuff. So yeah, like I'm so bad at like explaining what is in my head. So that made absolutely no sense. I'm sorry.
Oh dear.
I woke up really, really early today to study for my physics test. So I'm like dead tired.
Ew, physics.
I had it today this morning, and I didn't
How'd
even
you do?
it. Like I got A's on the first two, and this one was just like, I blame like the fact that I had to kind of just watch all of the lectures from last week this week. So
doesn't he drop the lowest exam grade anyways?
Yeah, but guess what? Exam 4 is when I'm in the Galapagos, so I don't know when I'm gonna take that. I have to email him.
Oof.
He already knows, but like I have to actually tell him again and be like, hey, when am I taking this? But
Fun
yeah.
times.
Yep, very fun.
All right, do you have anything else to say, Colin and or Jason? Whoa, Jason's room just got dark. Whoa.
I cut to close the blinds and turn the lights on.
I was like, wait a second.
Sun just set here in Norman.
Colin, do you have anything else to say? We can easily set up another one. Not like, well, Jason will be on vacation, but like, Colin, you don't have a life.
Yeah, you don't always get a Jason. That's
yeah. This is very, very rare. It's a rare sighting of the wild Jason.
No, looks like our MCS is getting going real good now.
Oh yeah.
We got that rear inflow jet coming up.
Boeing segment now.
Finally. This is also a really fun event to have watched. You guys, I mean, I think today's event actually would have been a really decent training event for us for summertime severe, to be honest.
Rip.
I mean, it was pretty good. We had a lot of interesting stuff. We had to contend with moisture transport. We had a pretty strong capping layer. We had disagreement between a special 19Z observed sounding versus the meso analysis.
I didn't see that.
Yeah, it was in the mesoscale discussion. Right, we had this development of the low over the last few days. We had it basically is following the cold. Those are the cold front, the warm front. I mean, that granted, that's typical of summer. But but a really good example on, the importance of the warm front placement. The warm front was the trigger, so that was good. Weak upper air support, but it was there. Some really great examples on how you calculate CAPE will change your CAPE answer. What other really great pieces here? Just because you have a whole bunch of CAPE doesn't mean you'll have convection. That was another good lesson for today. High base storms, that was another good lesson for today.
Are you talking about what's happening today?
Yeah. Yeah, like literally the storm in Kansas or Nebraska.
Yeah. You haven't gone over all these things today.
Huh?
We haven't gone over all these things today.
No. This is way too complicated for what we were trying to say.
Yeah.
Today was just introductory.
But there's a lot of great. There's now we can talk about flooding risk. We're getting reports coming of 4 inches of rain.
Yeah.
And
6 inches in Nebraska. Or 4 inches of sleet.
No
In
Cala.
Florida. I should have sent you a screenshot of that.
That's just hilarious.
Yeah, I would love to hold on here. So we can get some pretty good hail. There's a nice bonus. I mean, there's a lot of. I mean, there honestly this storm. I mean, I think.
What are you
the MCS was fairly well behaved. Oh, we also had the challenge of convection earlier in the morning to contend with.
Mm-hmm.
I think it was a great scenario.
Yeah, they had that tornado watch way too far west, though. They had to trim it.
Yeah, I'm sure they will.
They have.
Oh, they already.
Yeah.
I mean, there's some pretty significant rain numbers here. Also, I like this. 3.49 inches. Storm total thus far. Still raining.
Yep.
They actually have a flash flood warning for that area. They actually have 2 3-inch reports and 1 4.5. So, yeah. So this is these MCSs are basically what you get during the summer.
Yeah, I'm disappointed after what happened this year because if you noticed, Oklahoma had like no tornadoes.
It's because you showed up.
It's because I was here. Yeah, literally, there were tornadoes in Texas. And then there were tornadoes in Kansas. Like it just skipped over Oklahoma. We skipped over spring completely. Like we went from April to June immediately. Like there was no May.
Which was interesting because there were some, I mean, at least within Texas, there were some really interesting early spring events.
Yeah. Yep. Did you see my tornadoes I caught in April?
I think so.
Yeah, that was awesome. That was my first real tornado chase. It was so lucky.
Keep in mind, April was T-2 weeks from Dr. L's final for dynamics, so I was also a little preoccupied.
Mm-hmm.
Don't remind me.
I didn't mind dynamics.
I'm terrified.
Material.
You did well, didn't you, Colin? It was your favorite class. You said that was your favorite class, so I'm sure you did well.
Yeah, I think you stopped recording, right, Cassie?
Hold on.